When people imagine space, they think of stars scattered everywhere. But the truth is almost opposite. The universe is mostly empty. What's disturbing is that scientists don't even know most of what is out there. But NASA and scientists have given us the composition of the universe. About 5% of the universe is normal matter. Everything you see, everything you've ever touched, planets, moons, rocks, even you and me, that's called normal matter, also known as ordinary or visible matter. The rest, it is beyond strange. About 27% is dark matter. We can't see it, we can't feel it, but we know it is there because galaxies move as if some invisible glue is holding them together. Without dark matter, galaxies would spin themselves apart like a carousel going too fast. And dark matter gives the gravitational force needed to hold galaxies together in their place. Then there's the biggest part of the universe. 68% of the universe is something called dark energy. Imagine a mysterious pressure that is growing the universe and its boundaries, stretching the universe faster and faster, pushing galaxies away from each other into the abyss. Humanity has no clue what dark energy really is, but it dominates the universe. So here's the insane reality. All of history, all of science, every star discovered by the James Webb or Hubble telescopes exists inside that tiny, measly 5%. The rest of the universe is invisible, untouchable, and largely unknown. What's most interesting about the normal matter is that it is not spread evenly. That 5% of stuff is organized into something so strange, so massive, it makes our planet look like a dust grain in an endless desert. It's called the cosmic web. So, what is the cosmic web? If you could zoom out far enough, way beyond the galaxies, you'd notice something shocking. The universe isn't random, it has a structure. Astronomers call it the cosmic web. It is a gigantic network of filaments, knots, and vast empty regions. Picture a spiderweb stretched across the unimaginable size of cosmos. The filaments are made of galaxies, thousands of them strung together like glowing beads on invisible thread. Where the filaments intersect, you get dense clusters of galaxies. But the most mind-blowing part? Most of the universe isn't filaments at all. It is the space between those filaments, and those spaces are cosmic voids. These voids are so big they can swallow millions of galaxies, yet they're almost completely empty. The easiest way to think about cosmic voids is to compare them to vast oceans. Imagine you are in the middle of the ocean. You just see water, nothing else. If you're lucky, you will spot a lonely boat or a ship sailing out there, but mostly it's vast and lonely. Cosmic voids are exactly the same. Maybe you will spot galaxies in vast empty spaces, but typically it will be empty wherever you see it. The universe, at its largest scale, isn't a fireworks show of stars. It is more like a ghostly web stretched thin across endless nothingness. But how do we even know this? Could scientists be wrong? In 1980s, astronomers began mapping galaxies in 3 dimensions. And when the maps came together, the pattern was unmistakable. Galaxies weren't spread evenly. They formed filaments and left behind enormous gaps, the voids. These cosmic voids are vast regions spanning hundreds of millions of light years without almost no galaxies at all. To give you perspective, our Milky Way is about 100,000 light years wide. Some cosmic voids are thousands of times larger than that. One of the most famous cosmic voids is the Boötes Void. It is also known as the Great Nothing and was discovered in 1981. It is so gigantic it contains almost nothing. It has a handful of galaxies in a space that should have thousands. Astronomers call it a super void. The Boötes Void is nearly 330 million light years wide with just around 60 galaxies inside. Normally, such a huge space in the universe should have at least 2,000 galaxies. Now, these voids are not just empty accidents. They are part of the very design of the universe. They exist because of the way matter clumped together after the Big Bang. But here's the part that bends the mind. These voids make up most of the universe. Galaxies, clusters, stars, black holes, All of it are actually just rare dots floating in tiny regions between unimaginable deserts of emptiness. And yet, somehow, this emptiness itself might hold the key to universe's biggest mysteries. Let's go back to the strange breakdown of the universe. We know only 5% is normal matter. The rest is invisible, dark matter and dark energy. Dark matter is an invisible skeleton. It spreads through the cosmos, creating a hidden scaffolding and gravity that sticks to it. Without it, the cosmic web wouldn't even exist. Galaxies wouldn't clump together, stars wouldn't form, planets wouldn't orbit. Life, at least as we know it, could not exist. But dark energy, it is even scarier. Unlike dark matter, which pulls things together, dark energy pushes things apart. It is the reason galaxies are racing away from each other faster than ever. In fact, scientists discovered this by accident in the late 1990s. Astronomers studying distant supernova noticed that instead of slowing down, the universe's expansion was speeding up. Dark energy was at work. That is our only explanation. And here's the amazing part: it's spread evenly across space, meaning that the larger the universe grows, the more dark energy there is. It is like an unstoppable force, and it is winning. If it keeps itself going like this, billions of years from now, galaxies will drift so far apart that the night sky itself will go dark. A future universe where stars are invisible and silence is absolute. That is the destiny dark energy is steering us towards. So, where does that leave us humans? Here we are on a small rocky planet orbiting an ordinary star sitting in the suburbs of Milky Way, a galaxy that itself is just one speck in the filament of the cosmic web. When you zoom out, it is humbling. All of the human history, every discovery, every war, every love story, it all happened inside one galaxy, inside one corner of the cosmic web, surrounded by endless voids. It makes you feel small, but it also makes you feel something else: intrigued. Because somehow, in this tiny fraction of the universe, life emerged. And just not life, but life capable of asking these questions, building telescopes, and peering through the cosmic dark. The James Webb Space Telescope, for example, has given us glimpses of galaxies forming just 100 million years after the Big Bang. It is like looking back in time to the very beginning, and even from those images, the same truth emerges. Matter clumps, void spreads, and the universe builds its grand design. And now we come to the biggest question of all: where is this heading? If dark energy keeps pushing, the universe could end in what scientists call the Big Freeze, a future where galaxies are so far apart that sun burns down, new stars stop forming, and the cosmos becomes a cold, dark desert. But there are other possibilities. Maybe dark energy isn't constant. Maybe it changes over time. But scientists believe it could even reverse, pulling everything back together in a big crunch. Others imagine a big rip where expansion accelerates so violently that galaxies, stars, planets, and even atoms get torn apart. We don't know which ending is true, and maybe that's the beauty of it. But right now, we're living in a rare middle chapter, a universe alive with galaxies, stars, and planets, a universe with just enough structure, just enough time for life to exist and for us to wonder what it all means. So we are kind of lucky in a way, and maybe that's the most exciting part. Let me know what you think in the comments. And as always, thanks for watching.